Good morning student. Welcome back to my channel The Science Station. In yesterday's session I discussed Davison and Germer experiment. By this experiment we come to the conclusion that every matter is having wave nature. Now today I will discuss or I will explain Heisenberg's uncertainty principle. This is also very important. Before starting, please like, comment, share and subscribe my channel. So shall we start? First topic is Heisenberg's uncertainty principle. Before starting this topic, I will explain you what is the wave function. In the matter waves, a quantity that changes periodically is referred as a wave function. It is denoted by psi xt. Suppose we have two quantities. Suppose we have direction, wave is moving in this direction. So we have distance as well as we have time. Instead of showing separately distance and time, we write just xt. This wave is xt. Then psi, we call this function psi. Psi is a function of xt. That is a wave function. Now before starting this principle, I just want to explain you two topics. First one is wave packet. Group of harmonic wave, each slightly different velocity and wavelength with phase and amplitude, called wave packet. Suppose we have so many waves, they are comes together, they are slightly different phase and amplitude. We can write this delta x and lambda wavelength. So we can form one wave packet like this, which wave velocity of this wave packet is known as group velocity, which is represented by Vg. Okay, this is wave packet. Now come to the Heisenberg's uncertainty principle. The wave nature of particle is further studied by Heisenberg's uncertainty principle. According to this, it is not possible to measure the exact position and momentum of a particle at a time. Means, see, here we have a whole wave. So it is impossible to find the particular position or momentum of a particle. This is our Heisenberg's uncertainty principle. Now we have to find the expression for this Heisenberg's uncertainty principle. Suppose this wave, we have a wave, the change in the position is delta x, this is a y coordinate, x coordinate, and this is a lambda 0. Starting will be lambda 0. Consider a wave packet of matter waves width delta x. This is our wave packet having width delta x, group velocity Vg, phase velocity Vp. The wave number associated with the matter wave is 2k, k equal to 2 pi upon lambda. Why 2 pi? Pi equal to 180 degree. 2 pi means 360. The circle is having 360. That's why we are saying k equal to 2 pi upon lambda. K, where k shows the wave number and lambda is the wavelength. Instead, we know that lambda equal to h upon p. P momentum, lambda wavelength, h Planck's constant. Putting the value, we have this. If delta k, there is a small change in wave number, need to form a packet. If we have to form this packet, there is a small change. We have अभी हमारे पास इतना wave है, we just group that same amplitude, slightly different velocity, all waves together, we have this. If delta k be the change of wave numbers, need to form a packet the change in wave number implies the change in momentum. We can write if change in a wave number 2 pi h upon delta p, we can write. But we know that delta k and delta x, what is delta x? A measure position uncertainty, means this one is delta x, matter waves of the width. If delta x is very small quantity, is a less than 1, we know that this one. So what we have, delta x in vector quantity delta x, delta px is greater than equal to h upon 2 pi. Y coordinate will be delta y, delta py, and z coordinate will be delta z. These are the Heisenberg's uncertainty relationship. You have to write, when you have to ask such question, write Heisenberg's uncertainty principle and find expression. Then you have to write all these things for you. Till here you have to write. Tomorrow or in next video I will tell you, experimentally tell you how the uncertainty principle will work or will obtain, how the uncertainty principle will obtain. So till there, be with me, like, share and subscribe my channel, the Science Station. Thank you so much.